Hello, my name is Bret Davidson, and I'm here with my colleague Eka Gregoric, and we're from the NCSU Libraries here in Raleigh, North Carolina. If you'd like to get at our slides, they're available here. I'll give you a moment to grab that. Of course, you can just look up here, too, if you prefer. So our agenda for the day, we're going to take a look at open science as a problem space, and then we're going to reframe open science as modern research practice. And we'll talk a little bit about what we've been doing at NC State, particularly in the libraries, to engage researchers on campus in open science, and then show you how we're using Vagrant, Ansible, and Python to help researchers develop what we are seeing evolving as a modern research skill set. So this is our contract. If this isn't what you expected to see or you've changed your mind, you have a few minutes to leave before we lock the doors. So about 400 years ago, the Royal Philosophical Society published the first journal, really, in science, called the Philosophical Transactions, which covered the outputs of the ingenious people in the world. And they had this really handy motto called nullius in verba, which translates roughly to take nobody's word for it. Well, if we fast forward 400 years, it turns out that they were quite prescient. We can't actually take anyone's word for it. Or at least that's what this article published in 2012 in Nature tried to get us to believe, when it cited that a vast majority of cancer studies could not be reproduced. And this gained a lot of traction in the media. You've probably seen this barrage of discussion of reproducibility difficulties over the past few years in the media. And this term has kind of come to the surface, coined by the media, rightly or wrongly, as a reproducibility crisis. This is still evolving, and maybe the aggressiveness of this term has been scaled back a little bit over the past year. But there still seems to be a strong sentiment among science researchers and researchers generally that reproducibility is a big challenge. So when we're talking about open science, it's really an umbrella term for a number of open practices that you all may be involved in at in a different composition in your own work, whether that's open access to research output, or open data, open notebooks, or of course open source software. Really though, the philosophy of open science is a return to the first principles of scientific practice. And there's a pretty strongly held belief that open science can improve reproducibility. However, these open practices require new skill sets. So my colleague Eka is going to come up and give us a little bit more insight into what open science is.
Hi, everyone. If you can't hear me, wave or gesture or something, because I'm generally kind of soft-spoken. So as Bret mentioned, open science is this really broad umbrella term. And to really contextualize it and to give it some form, I'm going to lean on a definition that was crowdsourced from practitioners. It is an umbrella term that encompasses a multitude of assumptions about the future of knowledge creation and dissemination. And that's really important to kind of keep in the back of your mind as we're going through this. It's really about the way that research is carried out, the way that research is disseminated, and how digital technologies in particular are affecting the practice of science. A lot of the terminology and the conceptualization around open science comes from the open source movement, so there are terminological crossovers. There's a lot of iconography that kind of crosses over between the two. But the term itself was coined by Paul David in the early 2000s, and he's an economist and a historian, which I think is really important to note because this term did not come from the scientific community initially. It was kind of framed in the context of the knowledge economy, and this idea that the global economy is shifting towards knowledge objects, not material goods, being very important. And that open science, or openness in scientific practice, is one way for science to maintain relevance and to become more impactful going forward in this transition. But of course, open science isn't a new idea. Science, in the modern sense, as we know it, has always been open. And again, going back to this idea of nullius in verba, take nobody's word for it, the openness in everything you do is what reinforces that truthfulness. this is about the increasing fragility of traditional openness. And open science itself is a response to this crisis of reproducibility, which could also be termed a crisis of the scientific method. And that's, again, a fairly controversial statement because, of course, science can keep going even amid a crisis. It's not like everything's coming to a standstill just because there's a crisis of reproducibility. It's kind of a broader structural issue. And I think it's useful to understand it by going back to what the scientific method really is. And many of us in this room are familiar with it, but I think it's useful to step through it anyways. Essentially, science is not truth. It's a truth-making process that is exploratory in nature. It's about asking questions of nature through experimentation, uncovering possible answers to those questions, and sharing these answers so that others may question them. And the loss of reproducibility is really the loss of that last sentence. It's just sharing these answers to generate truth rather than having that double check. It's a trust action. And again, this is all very theoretical, really high level, and an umbrella term. So Sonke Bartling and Sasha Frisk, whose names I will never pronounce correctly, came up with 5 schools of thought to kind of compartmentalize the way that people are approaching open science broadly. The first is this idea of infrastructure, so actually building out technological solutions to support open practice. And the next is this idea of public science, which is about the accessibility of knowledge creation, particularly for publicly funded research, and making that research accessible to the public that funded it, as well as bringing the public in through citizen science efforts, which means normal everyday people can actually contribute to scientific practice, to research as it's ongoing. Then there's the measurement school, which is about alternative impacts. And essentially, this takes into account the fact that with the rise of digital technologies, the way that you measure what your research has impacted, what it has done, has shifted. Social media metrics are an example of alternative impact measurement. There's a democratic school, which is related to the public, but it's more global. It's this idea that access to scientific information is a human right. It's something that's cross-national, international. It's across countries, it's across communities within a country, across socioeconomic barriers. And it's fundamentally about the access to knowledge, which means not only making it available, but making it understandable by all of these different groups. So enabling that translation. And finally, there's a pragmatic school, which basically just takes into account the fact that a lot of scientific problems require a lot of brain power, more than you can house under one roof in one lab. It's too expensive to, maybe the skill sets aren't all in one place at the same time. So the pragmatic school is about taking into account these new challenges from the difficulty of conducting some kinds of research and just bringing people together to make it happen. And again, this has been really big in the news lately. A useful way to contextualize all of these broad ideas is through newspaper articles. And this is going back to a cancer reproducibility study. It was really big news in the early 2010s. And then also to contextualize it as not just a science problem, it's a social science problem as well. There's this great article by the Washington Post on austerity measures and the fact that a lot of the policy surrounding austerity measures came from a research article that was published without open data. And there was an Excel error that actually shifted one of their results very slightly. The authors of that original paper have since said that despite that error, their conclusions are still roughly the same. But it's scary to think that nobody noticed the error while making policies based on this research, policies that impacted the international community. And this is an example of citizen science in the news recently. The Flint, Michigan water crisis was kind of broken out and made public through a citizen science effort, community members contributing to the betterment of their community. And finally, the Zika virus. There's been a push by the scientific community internationally to make the drug discovery process for Zika open, and it is open right now. One of the big quotes from this paper was that there's likely already data that could contribute to this drug discovery process in proprietary environments, not accessible internationally as it could be were it open. So that's open science. That's kind of a broad context. Why are libraries interested in this? We are from the North Carolina State University Libraries. This is one of our wonderful libraries, the Hunt Library. Essentially, open science aligns with the core library values, such as information access, peer review, community-based knowledge creation, and the preservation and dissemination of research. It's really aligned with what we do. And open science is really reflective of modern research practice as it is forming. And libraries are also champions of open source and open everything. We're very big on enabling access to information. And we're fundamentally about supporting our users. We've always been a user-centric environment. For academic libraries such as ours, that means supporting research practice in whatever form it takes. And all of this is to say that modern research practice is experiencing this ongoing disruption from digital technologies, which is then impacting the way that we do our work. So it's very important for us to engage with it. And to, again, contextualize that disruption, here's a hypothetical open science workflow from the 101 Innovations in Scholarly Communication project, which is an awesome survey that asks researchers to report what tools they're using on a regular basis across every year, once a year. They've been doing it for over a decade. And you can kind of see that digital technologies have really integrated into every piece of the research life cycle. And that's useful to kind of understand how deep this engagement is and how diverse it is. There's also a broad policy shift in support of open. This is an OECD Science and Technology policy paper called Making Open Science a Reality. The US has been an OECD member since the 60s, and our policies here are directly influenced by these international decisions. And this is increasingly important for grant requirements. A lot of grants are requiring researchers to state open data deposit, open publication. So in order for research to happen, in order for people to get the money to do what they need to do, they need to be aware of these issues. So we went on an initiative to explore open science at NC State. And that's specifically within the NCSU libraries, the Open Science Initiative. Bret and I are representative of it. And our goal was really to explore open science practice at NCSU in our unique context and to better understand researcher needs in our context. And we did this through a very non-prescriptive, user-centered approach. A lot of user research went into it, which of course means creating opportunities for communication. Communication being the big deal. You have to talk to your users to understand what they genuinely need. We hosted an Open Science Unconference locally and had faculty attend and kind of talk to us about what open science meant to them practically. And then conducted informal follow-up interviews with anybody who expressed interest in the Unconference, essentially. And we kind of found two major issues that were universal across the board with anybody we talked to. There's a perceived modern research skills gap. There's a sense that there are skills out there that you need as a researcher that intersect with your work in some way, would enable modes of work that you're not engaged with yet, but you don't quite know how to pick them up or which direction to go in first. And there are insufficient incentives overall to enable the level of exploration needed to kind of figure out which skill set is the best for you. And so we started off with right off the bat, trying to address this modern research skills gap through the Summer of Open Science. Over the past summer, we held a series of 10 workshops, 5 per summer term at our institution, designed to address some of the biggest tools and topics that came out of this user research. and this is kind of a general idea of our promotion, we really shared collective knowledge within the libraries to develop this series and to kind of get the content out there. This is representative of our team, all of whom come from different departments within the libraries. And it was a series of workshops and events around scientific computing with Python, understanding your scholarly identity, as well as a series of meetups, which kind of continued the sense of communication and enabled community building, which was one of the goals of the initiative. And this is an example of our impact. This is a Python and scientific computing workshop in our makerspace. This workshop in particular had a 40-person wait list, which is kind of crazy if you think about it. And we found that there was a very dramatic interdisciplinary need across campus. We touched over 40 departments across over 16 colleges, ranging from the humanities to engineering to physics to anybody you can think of. And now I'm going to hand it off to Bret to talk a little bit about how that scientific computing with Python workshop in particular was iterated on and enabled through technical solutions.
So how many of you remember what it was like to start as a programmer? It's a pretty scary experience, right? You're not sure where to look for information. You may be familiar with the phrase imposter syndrome. I may be experiencing it right now, I'm not sure. It's important to note that when we're talking about supporting researchers on our campus, there's a huge range of support that already exists there. And our particular efforts are targeted at identifying the people that wouldn't be able to take advantage of something like, say, PyData Carolinas or a data science track on campus, people that had the interest and the domain expertise, but needed that first step into the technical sphere. They're obviously very intelligent people, well socialized, and if we can help them meet the right people and give them the right starting points, they can be very successful on their own. So this web scraping with Python course, when we look at it as experienced developers, we probably look at this list and say, yeah, that's no big deal. I can do everything on that list, sure. I know Python's data structures. I know how to import a library. I know how to use requests. I know how to retrieve a web page and scrape it. Sure. I've made a visualization probably more sophisticated than a word cloud. I know what control structures are, exception handling. We all do a good job of that, right? And I know how to work with the file system. I can read in CSV data or retrieve it from an API. Of course, to a novice, none of these things are trivial. And this is what we were able to cover in a short 2-hour, 45-minute workshop. But on top of these very explicit learning outcomes related to Python skill acquisition, there are a lot of implicit skills that are assumed oftentimes in these environments. How do you use a command line interface? Do you know how to interact with a web server on your own machine? What text editor do I use? Should I use 4 spaces or 2? Should I use tabs or spaces? These deep-seated questions that can actually break programs in particular languages. So we were able to go a little deeper than just some of these explicit requirements, but also some of these implicit ones. And when we first taught this course, we identified a number of challenges for our attendees. First, it was incredibly difficult to get consistency across our user environments. I have one researcher who comes in with an 8-year-old Windows machine, someone who comes with a Linux box, who thinks they're a Linux guru but really isn't, and you have someone who uses OS X and has never opened the terminal before. This is great. This is a representative population. But how do we teach to this environment? Everyone has different versions of Python. They may not know how to use pip. It's very challenging as an instructor, which makes the creation of course materials that can then be taken from the classroom and used for individual learning almost impossible. If you've ever tried to write a blog post about a tutorial, you've probably received comments following up. Oh, you didn't cover my exceptional edge case. I didn't know your edge case existed. If I had, I might have considered it. Then there's also this challenge of how quickly can we get a workshop up and running. You know, probably it's very difficult to make sure everyone has the same package running the same version. And then, of course, how do we draw people together from our own organization, in this case, the NCSU libraries, to help contribute learning materials to this project? There are a lot of approaches that one could take to sort of support this sort of learning environment. You could create custom operating system images, which end up being pretty large, maybe hard to distribute. You could lean on custom distributions like Anaconda, which is marvelous, of course. Or you could use the really rich interactive environments like Jupyter, which we saw a lot of great success with, I think, yesterday and today. The approach we elected to take was to take a look at some virtualization tools designed for developers and provisioning tools designed for server management and configuration. So we used Vagrant and Ansible together to help us create lightweight, localized, repeatable, reproducible computing environments that were easier for us to maintain because the outputs of them, rather than being a large disk image, were just text files that we could put into our enterprise GitHub system and edit and share very easily. Just a quick show of hands, how many people have used Vagrant or heard of it? How many people have used Ansible or something similar, Chef, Puppet? Yes, great. So a quick introduction for those that aren't familiar. Vagrant is really at its simplest a tool for helping to coordinate virtual images, often through VirtualBox. Their ad copy says you can create and configure lightweight, reproducible, and portable development environments. And it's extremely easy to use. There's a binary installer that you can put on your machine. Once you've installed Vagrant, it will also install VirtualBox. You type Vagrant init, and it creates an initialization file that's just simply a text file written in Ruby. But it's written in Ruby. And then you run a single command, Vagrant up. It reads that file, and your environment is scaffolded, assuming that you've plugged it in with a provisioner. And I know this is difficult to read on this particular screen. I encourage you to take a look at the slides at home. The big thing to take away here is that this is a single text file that's 27 lines, and it wires up the entire setup of a computing environment that we used on 40 machines for a classroom experience. The first 15 lines or so are simply about selecting a virtual image to download and configuring the ports to access it so that you can view web programs on the browser. And then this last little block is the provisioner block. Vagrant comes configured to work out of the box with a number of provisioning tools. In this case, we chose to use Ansible, and you can just point to an Ansible playbook, and it stands up your system. So what is Ansible, you might ask? Well, their ad copy says they're an automation engine for provisioning, configuration management, app deployment, and other IT needs. Okay, provisioning means to make something available. I understood it when it told me that this means installing packages. This means putting libraries, software systems, tools onto my machine that I need. And then this question of configuration management is how do I wire these things up so that they work with each other consistently and repeatably. Here's a very simple example of a playbook. In this playbook, the first 8 lines or so are just some metadata about the environment that you're provisioning to. And the real meat and potatoes, if you will, are lines 9, 10, and 11, where you link out from your playbook to some roles, which is a sequence of installation activities. So if you remember back to the Vagrant file is pointing to this playbook. When it provisions, when you run Vagrant up, it calls this file, which starts Ansible. When Ansible stands up, it says, okay, I need to execute these roles. And here's an example role. Again, I apologize for the text size. Essentially, though, this file, not following Ansible best practices for the sake of this example, but we have basically a set of tasks that are doing the provisioning for our environment, where I'm using the apt package manager on the Unix environment image that we downloaded to install a number of baseline requirements for the tutorial environment. And then the last 2 directives are doing some of the configuration management that we needed for the environment. Direct a user to the correct directory when they SSH into Vagrant, and set a display variable so matplotlib works through virtualization. If you want to take a closer look at this environment, you can pull it up. It's at github.com, NCSU libraries, Python, Vagrant. This is a very immature environment. It was really a test environment, but it'll give you a sense of what we were able to do with it. This is all so that we can make this process of standing up an instructional environment easy for researchers when they come in. And it really is a 5-step process. Once they have Vagrant installed on their machine, they can clone this Python Vagrant repository or download the zip file. They navigate to it through the command line interface, execute Vagrant up. After 8 or 10 minutes, depending on the network performance at that particular time, the Vagrant environment will be stood up with all the requirements that they need for the course. The operating system, the Python environment, the Python dependencies that we're using, and all that configuration that we highlighted. The user executes Vagrant SSH, they're inside the virtual environment, and then they can execute Python code. So we've obviously put a lot of emphasis on how we've been using these tools to support researcher training. We see this as just the very first step for what we'd like to do. As Eka said, this is the result of a trend not only of open practices and open influences, but also changes in how research is conducted. This is really why PyData is here, right, is this shift towards this huge emphasis on data science as a core skill for any sort of research-oriented investigatory practice. So what we want to do moving forward is to take this sort of very basic instructional environment, move it towards something that's better suited to more serious scientific computing. Can we expand on like the Vagrant environment that Anaconda has put together and integrate that with some other tools that we use? Can we expose for our attendees some of the things that are underlying this process of writing web applications? So I mentioned before that there are a lot of implicit requirements into a course. One advantage of using these, something like Ansible where you're provisioning, is that you have a written record of what actually is required to get the environment running. And you can expose that to the attendee as a learning tool so that they can understand how their environment is working. Kyle made this mention this morning in his keynote that I thought was really right on target. It gives you a better sense of how the system itself is functioning. And then we'd like to go a little further and optimize the relationship between the images that we pull down. Right now we're just using a generic Unix image with a GUI. But we'd like to maybe enrich that a little bit to decide where exactly we're separating those concerns in our process and make the correct balance between disk images, provisioners, and our tutorials. And once we go through some of this process, we're going to try to make this happen in something we're calling scholarly backpacks. We're going to try to attack this from 3 angles. We want to create a virtual environment that supports researchers with general research tools, things like Tableau for sort of very entry-level visualization, research citation tools, and that sort of thing. But then explore more robust environments for data science using things like Anaconda, NumPy, SciPy, etc. And of course, when is there demand for some sort of visualization-focused research environment these days? And we're going to take these environments and take them out onto campus, and we're early stages of finding partners for this process, but we're very confident that we'll be able to put these into curricular use on campus to help next generation researchers sort of get a leg up on developing these skills, but also to test them out in a real laboratory environment to see if it holds mustard. So very quickly, in summary, we're arguing that an emphasis on reproducibility and this shift in digital tools has ignited a shift toward new practices in research. With these new practices come new requirements for researchers, both in terms of the infrastructure that they're working with, but also in terms of the skill set that they have themselves. An outgrowth of this is that reproducible and portable computing environments are critical for future success. We need to be able to reproduce an environment from my machine to your machine to wherever we have it on the cloud, so that we can be confident that our scientific conclusions that are derived from code executing in these environments is valid and consistent. And finally, we think tools like Vagrant and Ansible and others can help researchers develop these scientific environments that they need to be productive moving forward. Thanks very much. Really appreciate your time. Questions?
Excellent presentation. I have really kind of 2 maybe comments or questions. more on the open sciences front, one kind of philosophical and the other pragmatic. And I'd like to hear your opinions. On the philosophical side, you know, we've seen over and over just devastating, in some cases, corruptions of data and analyses, fabrications even. In fact, recently there was a $200 million worth of cancer research was funded, and it was based on fraudulent manipulation of data in this area. And when you think about that at a philosophical level, it has to be linked to this incredible emphasis on monetizing fundamental research in a closed environment. There are forces that want to capture intellectual property early, and it causes huge issues. So it really kind of goes to maybe an underlying element of this. And the second kind of question is on the more pragmatic level. Every time you turn the corner and you try to look up some research, whether it's online or wherever, you see these wonderful articles. You want to sit down and read these articles to understand it a little more, or maybe gain access to the data to understand what they've done. And you pop up with, you know, you can download this article in a PDF for $59.99, or you can look at it for, you know, 2 days for $39. And all of this research is funded either by institutions or foundations or the government. And then you turn it around, and at a very pragmatic level, you lose access to it because of these barriers. So, you know, I'd like to hear what you guys have to say about that.
So to start with, our opinions are our own and not those of our employer. You should be a librarian. These are the issues I think that we're struggling with in a lot of ways. And I want to give Eka a chance to respond. The one thing that I would say from a philosophical standpoint is, and what we've been trying to advocate on our campus as we've made an argument for open practice, is that we don't need to just flip the switch and go all open. Progress can be made if we adopt a spectrum approach where we at least try to make progress toward being open as much as we can. There's incremental benefit to be gained while working toward the philosophical goal of being truly open. But Eka.
I just want to comment on the first half of your question, which is there's a notion of a legacy gap in relation to open science, this idea that we are in a moment in history where infrastructure, which includes policy and includes the way that metadata is handled, includes everything associated with research, has not caught up with the digital infrastructure possible. So things are in use that policy and infrastructure have not caught up with. And something similar happened in the Middle Ages with medieval guilds, particularly in Europe, where in order for a guild to really assert itself, they would keep information about the way that they did something specific very close to home. And it was very difficult for practitioners to move between guilds. The thing that enabled that motion of information was patent law. So we're in a moment prior to patent law, basically. It's just not patent law in this case. It's a broader infrastructure shift. So philosophically, that's where we are. And I don't know that we really have any conclusions on that from our standpoint. It's just a very complex moment in the history of science.
And back to your question about the pragmatic issue of being charged for data. We have a number of initiatives in our own library towards trying to move people toward publishing in open access journals and open access data repositories. These come with their own challenges where researchers are asked to front the publication cost or the perceived publication cost of their research. Libraries try to be advocates for that work as best as we can. We see it as a terrible crime. I mean, I have to admit, it's extremely frustrating to see impactful research like that be constrained in a way that people can't apply it. The whole first principles of science that we mentioned is this idea that progress is built on the shoulders of those that come before you. And if you can't access their work, you can't build on it. It doesn't really solve the question, but great questions. Yeah.
This is more of a question on the technical implementation side. It sounds like, based on the way you're using Ansible and Vagrant, that something like Docker might actually meet your needs better because it would be sort of the containerized provisioning of Linux and configuration in one fell swoop, especially with recent advancements in stable versions of Docker running on all environments, not just Linux. So could you comment on why you made this specific architectural choice as opposed to something else like Docker?
Sure. So we've also been investigating Docker for some of our other work for the applications that we write. We just weren't along in our implementation to apply it at this point. I agree that from a scalability standpoint, Docker kind of meets this intersection very nicely, and it's certainly an approach worth considering. Yeah. We didn't rule it out for any technical reason. It's a socio-economical concern with the timing of the workshop. Thank you.
Hi, this is a really exciting talk to me. I'm not a scientist, but I've been studying this. I know that you need constraints. This is such an expansive project that being able to just work with NCSU is probably a lot. But I would love to see an opportunity for people outside of the NCSU fence to access your work. What concepts do you have about sort of allowing some portals into what you're doing to the outer community?
Everything we do is open. We publish openly on GitHub, so we do encourage community members to comment on our work and to contribute ideas.
Yeah, and we're at the phase with our program design where I think some of those opportunities for broader community participation will be more visible. This investigation has really just started with the two of us as a portion of our time, and we're moving towards, it's in conjunction with a variety of other initiatives happening in the library around issues of open access, research data management, open source software. So this particular focus is still emergent in our library. But we'll try to put a little bit more up on our library website, perhaps, to show some access points to this. Thanks.
So when you said perceived costs to researchers of open access, I'm curious, are there ways to make those costs go down? Because it's looks like it's way more to have something open.
I guess I was being overly cynical. Which is perhaps a mistake to make when a mic isn't in your mouth. I was suggesting that perhaps we don't have a clear picture on the true costs of publishing, and that costs that are passed on to researchers or libraries may not reflect the true cost.
So thank you very much. This is a great talk. Thanks.
Thanks very much. Appreciate it.